Assalamu alaikum. Today I will discuss voltage transfer characteristics or VTC of CMOS inverter. At first, have a look at the circuit of CMOS inverter. So here we have a power rail called VDD. This is high voltage or digital 1. Okay. Now we have a PMOS directly connected to the VDD, and the source of the PMOS connected to the VDD, and we have an NMOS that is connected to the ground, and the source of the NMOS is connected to the ground, and there is a common drain. We tie the drain of two transistor, the drain of PMOS and the drain of NMOS is connected together, and we get output voltage from this common drain. Okay, and we have a common gate also, and we give the input in this to this common gate. Okay, right. Now we'll analyze how this inverter circuit works, and we'll name some voltage, current. Suppose what will be the voltage VDS of NMOS or drain source voltage of NMOS. That means this voltage VDSN. The voltage difference between the drain and source of NMOS. The drain voltage is V out and source voltage is 0. So VDSN will be simply drain voltage minus source voltage ground voltage, that means 0 will equals to V out. Okay, so now VDSP, what will be VDSP? This voltage is drain source voltage of PMOS. The drain voltage is V out and source voltage is VDD. So difference between these two node voltage equal V out minus VDD. Okay, so VDSP will be simply drain voltage of PMOS, that is V out, minus source voltage of PMOS, that is VDD. Okay, now the voltage VGSN, NMOS gate source voltage. Okay, the gate voltage is equal to the input voltage there, because the gate is directly connected to the input, and the source voltage of NMOS is ground. So VGS N will simply V in, that is gate voltage, minus source voltage is 0, that will be only V in, and gate source voltage of PMOS will be, the gate voltage of PMOS is input voltage because it is connected to the input, and the source voltage is VDD. So the difference between gate source voltage of PMOS will be V in minus VDD. Okay, this voltage is VGSP. Now current, let's see current. We call the upward current is drain to source current of PMOS, and downward current we call drain to source current of NMOS. So because yeah, in this node the two current is outward, we can simply write IDSP equal minus IDSN according to the Kirchhoff's current law. Okay, right. Now we will analyze the IV characteristics of NMOS and IV characteristics of PMOS that we have learned basic electronic courses. Okay, we know for an NMOS, the drain source current versus the drain source voltage curve will look like this, right? This lower curve is for lower gate source voltage, and the upper curve is for higher gate source voltage. So we can write it, let's say this is for lower gate source voltage. Let's say this is for 1 volt gate source voltage, and this is for 2 volt. The higher the gate source voltage of NMOS, the higher the drain source current, right? Now we'll change this parameter. What is GSN? We derived already. GSN is V in equal V in, so we can write V in instead of VGSN. Okay, because they are equal. Okay, this is for NMOS, and we can change this VDSN also. The drain source voltage of NMOS is V out, we derived already, so we can write V out instead of VDSN, right? Okay, now we'll draw this curve for PMOS also. For PMOS, the drain source current will be negative because for PMOS the current starts from source to drain, so that's why the current is negative. And also the drain source voltage negative because the drain voltage is lower than source voltage for PMOS. That's why we get the exactly same curve at the third quadrant, right? The current and voltage both are negative. Okay, now this is for lower gate source voltage, that is -1 volt. If we take the modulus, then this curve will be the higher gate source modulus of gate source voltage. This let's say this is for -2 volt. Now we will try to match this axis. So here for NMOS the y-axis is IDSN, but for PMOS it is IDSP. We will try to change this axis and we will try to match IDSP to with IDSN. Now we will also change the x-axis. We have VDSP for PMOS, but we have V out for NMOS. So we will try to change this axis to V out so that we can draw these two curve in a single plot, right? So IDSP, what is the relationship between IDSP and IDSN? We derived it already. IDSP equal minus IDSN, because there is a negative sign. So if we change this axis, the current will be positive. If we change this axis to VDSN, the current will be turned from negative to positive. So this will be the curve if we change the y-axis only. Okay, so now we will change the parameter also. Here the parameter is VGSP, but for NMOS it was V input. Then what is the relationship between VGSP and V input? Here we have this relationship VGSP and V input. So VGSP equal V in minus VDD. So if we change the parameter, VGSP equal V in minus VDD. Let's say VDD equal to 2.5 volt. So here V in will be VGSP plus 2.5 volt. Now for -1 volt, what will be the V in? For -1 volt, V in will be simply, if we put this -1 into this equation, -1 plus 2.5, that will be 1.5 volt. For VGSP equal to -2 volt, what will be the input voltage? V in will be -2 plus 2.5, that means 0.5 volt. So we can change this parameter also. Now for this, V in equal 1.5 volt. For this, V in equal 0.5 volt. Now if we change the axis, the current turn from negative to positive. So the lower curve will be -1.5 volt. This will be for V in equal to 1.5 volt, and the upper curve will be V in for V in equal to 0.5 volt. We change the parameter also to match the NMOS curve. Okay, now we have to change the VDSP, right? So what is the relationship between VDSP and VDSN? So VDSP and VDSN relationship, VDSP equal V out minus VDD. We will use this equation. So VDSP V out minus VDD. We assume VDD equals 2.5 volt. So if we change the axis VDSP to V out, the curve will shift rightward because there is a -2.5 volt. So 2.5 unit rightward shifted curve will be okay. So that the shifted curve. If we shift this curve rightward 2.5 unit, we'll get this exact curve, but shifted rightward, and we change the x-axis to V out, right? Now this curve has y-axis VDSN and x-axis Vout, that is exactly same as the NMOS curve. Now if we plot the NMOS and PMOS curve in a single plot, sketch the NMOS and PMOS curve in a single plot, that will look like this. This is for PMOS. We have derived, uh, and this is the white curve is for NMOS. Now we will try to find the transfer characteristic, that means V out versus V in. Now here look at the curves, the V out is x-axis, but here V out is y-axis. Now we start from the lower input voltage. For lower input voltage, let's say V in 0.75 volt, the NMOS curve is this and the PMOS curve is this, the intersection here. The intersection point will be the operating point, right? So intersection point near the 2.5 volt. So for lower input voltage like 0.75 volt, the intersection for point is nearly 2.5 volt. Now let's V in equal 1.25. For V in equal to 1.25, this is the NMOS curve, 1.25. This is the PMOS curve. Input voltage 1.25. There is many point or several points, not a single point intersection. So here the output is changes from here to here, so output drops significantly, but input is nearly 1.25 volt. Then so we can draw it like this. The input is 1.25, but output, there are many intersecting points, so there are many points and output drops from high to low. Now for input voltage equal 1.5 volt, this is our NMOS curve and this is our PMOS curve. The intersection point nearly 0. So for 1.5 volt input, the intersection point or output is nearly 0. So if we connect this curve, we'll get a curve like this. If we connect the points, we'll get a curve like this. What does it mean? For lower input, the output is higher. For higher input, output is lower. That's how an inverter works, right?